Okay, guys, for this one right there, which linear graph is shown? I would just graph each one, but to graph each one, I would minus 7 on this one. So look at all these numbers, put the opposite, right? So for this top one, I would have y is equal to a negative 3, x minus 4, minus 7. And this one here, I would have y is equal to a negative 3, x plus 2, minus 1. All right, just do that. And you can see it from there. Yeah, that's it. So I'm going to go to graphs. Do my bad. Oh, why is it already there? My bad. Let me see. Negative 3, x minus 4. Again, I'm isolating the y, okay? And I'm going to minus 7. Ooh, that one looks like it actually. 1, 2, 3, 4, 5. Check. 1, 2. Oh, yeah. That's my answer. Yeah. Answer is that one. Aren't you going to prove that the other ones are not it? Or y equals to my minus e1. We're going to go negative 3, parentheses, x plus 2, and minus 1. Not even close. And then we're going to go adding 4, which gets rid of that. So we're going to go 3, parentheses, x plus 7, plus 4. Not even close. Double check. 3x, x plus 7, plus 4. Yeah, not even close. 3, and then we'll go x minus 1. And to get rid of that one on the side, plus 2 over here. Nope. I like my answer H. Okay, which is a factor? Okay, so the other day I did this one. I'm just going to go and do this part right here. Create the other one. Time out real quick, guys. Okay, so for on this one, guys, I'm going to create the other number that would go here. 3 times what would give me 9r squared, be 3r. Negative 1 times what would give me a positive 1? Negative 1. Okay, so I went to do my math here. This time this gives me a 9r squared, which I wanted. This times here gives me a negative 3r. This times here gives me a negative 3r. When I add those together, it does not give me that. This one times which other one? R times what would give me 9r squared? 9r. The last one, 1 times what would give me a positive 1? I'll do that. So I'm going to just do the work now like this. R times 9r with 9r squared. And then r times this, negative r. Negative 9r. These do not add up to that. No. There's a 9r, negative 1. I think it's just this one again. 9r times what would give me what? All right, there. Negative 1 times what would give me a positive 1, negative 1? That's basically this, so no. I want to say there are no real factors. Okay, so the graph of this line right here is shown below. The order pair and solution set. Which order pair is in the solution set? I don't even know what to tell you. Okay, so what I'll do, minus 2x, right? Then I would divide by negative 5. So when I divide by this negative 5, okay, let me just show you. Go a little slower. So to get this one here and then see which side I shade, I'm going to shade the bottom. Just by me looking at the work I would do, but let me do the work. So I would subtract 2x, cancels out here. We're going to go to negative 5y, greater than or equal to a negative 2x, plus 10. Then we're going to divide by negative 5, divide by negative 5. When I do that, this cancels out. We're going to go to y. That switches this out, guys. It switches it out, okay? That part right there. And there's my negative 2. There's my slope of 2/5 right there. Okay. Shaded, you see this y is less than, so I'm shaded below. Now I need a point that's just below it. 0, 5, out. 5, 0, ooh. I like that one. Negative 2, 5, out. Negative 5, 2, out. Or another way of doing it is just get these coordinates, plug it in there, and then see if it's true or false. So what do you mean, sir? Okay, so not trying to calculator. This is probably the easier way in case you don't like all that work and thinking. So you see it's 2 times 0. And I'm going to use this point, plug it in there. I'm going to go with 2, parentheses, 0, minus 5 times my y value of a 5. Right here in this blue area are the inequalities, so I'm going to control the same symbol I see there, and then put 10. False. The one I came up with the answer, this one, I'm going to do the same idea. And then go 2 times 5 minus 5 times my y value, 0. Control this. Same symbol, is it that one? 10. Sure. So that's my answer. Okay, so enter the statement of bacteria sample. The function this one gives the number of bacteria in the sample at the end of the X days. So this is a starting point, and it grows by that much, 0.12, and it's a growth. Okay. Initial is 12, wrong. Well, we want the one the best. Initial bacteria, it decreases, no, it's an increase. Increases by that much, yes, I like that one. The number of bacteria at the end of day 1 is 245. Actually, at day 1, you put a 1 here, right? Okay, so when you multiply 245 times this, because that means this 1.12 right here, when it becomes a 1, it just means that. So I multiply 245 times this, it's already more than 245. Okay, all right, this is pretty cool. I like this real quick. Oh, without even reading the question, range x, x is our out. Okay, these are my y's. Cool. First thing it comes are x's, domain. Second thing comes are your ranges, your y's. There's a daily cost of hiring a plumber at y, okay, the cost to work x hours on a repair project can be modified using the linear function. The number charges a fixed cost of 80 plus an additional cost of 45 per hour. And then right here, the plumber, works a maximum of 8 hours per day. So this is the cost, right? The y. 8 is kind of the max, okay? For 1 day of work, what is the range of the function of this equation? So you kind of look at this thing right here. If he works the average, how do I say that? What if he shows up at work? You got it? But he doesn't put in a whole hour. He still gets charged 80, right? All right. Now, what if he puts in that much, and then what's the max he does? He still gets charged at 80, and then he gets the 8 hours in. I don't even know how to do this one as far as in my head. 40, 32, 36, plus 80, 440. So that's that max right there. But boom. Okay? Going once, going twice. Good question here, guys. The graph of g of x is x squared, which transforms to create the graph of h of x. Which of the following describes a transformation? I can't tell you what to do on this one besides, or I can. Just graph it, as simple as that. El gráfico. El gráfico. Graphs. We're gonna x squared. It was transformed to make this other one, so I'm going to go to tab. But boom! It was okay. When it's flipped over like that, it's called reflect. And then let's read the other words. The other words are kind of funny. Okay. Reflected over the x-axis. This is the x-axis. You see it went up, now it's going down. Cha-ching, I like that. Over the y-axis, no. Reflected over the x-axis, yes. Horizontal stretch means like they got like a, you know, like I just like to say marshmallow, and they pulled it to the side. And now it's a flatter, wider. Did I say mushroom? Marshmallow. Marshmallow. Actually, that's my answer right there. Sweet. Okay, guys, let's go and work on this. Okay, guys, here's on this real quick. This is a real good question. This is like really, really good. I'm trying to figure out if I should continue or stop. Okay, so this part right here, I'm going to break this part here and I'll do that one. This right here is 5, all right? And we're going to have Q on the top to the 5th. And the W's, you're going to have, I'll step over here, W to the 7th minus the 3, which gives you W to the 4th. So now that comes W to the 4th on top. Okay, so that's this part, over 1. This part over here, you're going to have a 4. These two right here, you're going to have, step to the side, Q to the 6 times 2, which is Q to the 12. And then down here, that one comes up, because this negative down here, it'll come up here, W to the 5th. And that's kind of it, really. Now, you multiply them together. Multiply 5 times 4, 20. Q and Q, you actually add those up, so you're going to have Q, you add them up. You're going to have Q, 5 plus 12, which is 17. Q to the 17. And then you're going to have over here the W and that W. You're going to have W to the 4th plus the 5th from the other one, which gives you the 9th. And there's your answer. 20, Q 17, W.
7th grade pickup students can be released. 7th grade pickup students.
Let's look at this one real quick. A graphical quadratic function is shown. A vertex. Yeah, that's easy, guys. That's this corner. This lowest, maximum, or minimum. In this situation, it's a minimum. You just get that coordinate. 1, -2. It's a joke. Wow. Okay, we're going to finish it up, actually. So the line that passes through those 2 points, we'll do it really easy. I'm just going to come out here, open up the calculator. Let me zoom in here. Look how I do it, guys. It's finding the slope of that line.
Eighth grade
Turn on here.
students, pickup can be released. Thank you and have a great day.
So 5, -11, -9, 17. And here, menu 413. I'll go to B, control this. The slope of the line, -2, -2. That's it. This is asking what is the x value to the solution. So on that one right there, x value of the solution, okay, I'm just going to go ahead and use the calculator, guys. I hate to say just go to the calculator, but this, it's not cheating, it's just allowed. Okay? So we're going to come out here, go to menu, 3, 2, both right there, type it in, and we're going to go x equals 2y minus 4, 7x plus 5y equals -66. Question is asking what is the x value to the solution, -8. I kind of like the way the green looks. All right. Again, it's in the calculator, menu 3, 2. Oh, this one's an easy one. Which one's equivalent to that one? So the square root, control square root, you see it right there, of a 96. Not that one. Obviously not that one. It's not that one. It's going to be this one. Or control this one, 6. Okay. This one's asking, let me see what it's asking. Which line appears to have x-intercept of a -5 and y-intercept of a 3? Okay, x-intercept of a -5, out. Actually, that's all you had to check, because this one doesn't. That's a joke. That's actually a cheap question. I can't believe they put that in a STAAR test.